You see that rock? The one everyone steps over, kicks aside, or tosses into the weeds. That is the one that could be hiding a fortune in opals, rubies, or even diamonds. The ugliest rocks on Earth are nature's best kept safes. And today I am handing you the X-ray vision to see straight through the crust. Most people throw away their shot at a fortune every single day, simply because they do not know what to look for. But if you stick with me, you will learn the secrets that turn a dirt clod into a treasure chest. And you will never walk past a creek bed, a gravel bar, or a mountain trail the same way again. Professional gem hunters know something you do not. The world's most valuable stones rarely announce themselves with a sparkle on the surface. Some of these rocks are rarer than diamonds, and the only thing separating a doorstop from a $1 million find is the knowledge to look deeper. By the end of this video, you will have the X-ray vision to spot nature's hidden fortunes, no matter how ugly the shell. Let's start with the potato of the mineral world, the geode. You've seen them, lumpy, round, and about as exciting as a dirt clod. Most folks wouldn't give them a second glance, but inside, that's where the magic happens. Crack one open, and you might find a cathedral of amethyst crystals, quartz points, or swirling bands of agate. The secret is hydrothermal activity. Mineral-rich water seeps into a hollow cavity, often left behind by a gas bubble in ancient lava or a decayed root. Over thousands, sometimes millions of years, those minerals crystallize, building a hidden treasure chamber. The outside is hard, bumpy, and dull, usually a shell of chalcedony or quartz. Pick one up, and you'll notice it is lighter than it looks, sometimes with a faint rattle if loose crystals are inside. That is your first clue. And here is the science. Geodes form in volcanic or sedimentary environments, where gas bubbles or dissolved nodules leave behind empty spaces. Over time, mineral-rich fluids seep in, and as the temperature and chemistry change, crystals start to grow. The process is slow, sometimes taking millions of years. The color of the crystals inside depends on trace elements in the fluid. For example, amethyst gets its purple hue from iron ions and natural radiation. If you're lucky, you might even find opal geodes like those discovered in Ethiopia's Welo region, dull on the outside, but inside a kaleidoscope of color that can fetch thousands of dollars per carat. So how do you spot a geode in the wild? Look for round or oval rocks with a bumpy, nondescript surface, gray, tan, or brown. They are often lighter than they look, and if you shake them, you might hear a faint rattle. Geodes are common in volcanic ash beds, limestone deposits, and even some river gravels. The best way to open one is to score the circumference with a chisel, then tap gently with a hammer. Never smash it outright, or you'll shatter the crystals. Always wear eye protection. In the field, a geologist's hammer, a sturdy chisel, and a pair of gloves are your best friends. Now let's talk value. Unopened geodes might sell for $5 to $50 at a rock shop, but a single opened amethyst cathedral can fetch thousands of dollars. One famous specimen, the Empress of Uruguay, sold for over $250,000. At mineral shows, large, vividly colored geodes routinely sell for $10,000 to $30,000. Even small opal geodes from Ethiopia can bring in $1,000 per carat if the play of color is strong. This is what nature hides from the impatient. But just when you think you have seen it all, the next rock on our list makes geodes look like child's play. Imagine a rock that looks like it was dug out of a construction site, gray, crumbly, and streaked with rust. That is pegmatite, or as I call it, rotten granite. Most people walk right past it, thinking it is just a busted up chunk of old mountain. But inside, pegmatite is the birthplace of giants. We are talking emeralds, aquamarines, tourmalines, and even rubies. Crystals so big, you could use them as paperweights. The science is simple. Pegmatites form in the final watery gasp of a dying magma chamber. As the granite cools, water and rare elements get squeezed out, creating pockets where crystals can grow unchecked, sometimes as big as your arm. The low viscosity and high mobility of the fluid phase allow for rapid diffusion of ions, which is why pegmatites can produce crystals meters in length. Look for massive, blocky textures, light colors, and interlocking crystals. If you spot graphic granite, quartz, and feldspar intergrown like ancient writing, you are in the right place. Here is a real-world story. In 2004, prospector Steve Brancato was climbing near the summit of Mount Antero, Colorado, when he cracked open a weathered pegmatite dike. Inside, he found Diane's pocket, a vug packed with aquamarine, feldspar, mica, garnets, and black quartz. The specimen measured nearly a meter across, and the aquamarine crystals alone were valued at tens of thousands of dollars. In Maine, colored tourmaline crystals have been pulled from pegmatite pockets, with fine specimens selling for hundreds to thousands of dollars per carat. And in the Pala district of California, a single kunzite crystal from the Big Kahuna pocket fetched several $1,000s. So how do you identify pegmatite in the wild? Look for coarse, blocky rocks with large interlocking crystals, white, pink, or gray. Pegmatites often cut through granite or metamorphic rocks as dikes or veins. If you see graphic granite, quartz, and feldspar intergrown in a cuneiform pattern, you are onto something. Use a jeweler's loupe to examine crystal shapes and cleavage planes. Pegmatite gems often show well-formed prismatic or bladed crystals. And if you find a pocket, break it open gently. Score around the edge, then use a chisel to pry it apart. The biggest mistake amateurs make is smashing the rock and destroying the crystals inside. Value check. Pegmatite is a major source of high-value gems. Tourmaline rough can sell for $50,000 to $2,000 per carat, aquamarine for $20,000 to $1,000, and emerald for $100,000 to $10,000 per carat. Colombian origin commands a fourfold premium. Large, well-formed crystals from famous pegmatite localities can sell for $5,000 to $100,000 at auction. In 2024, a 22-kilogram beryl crystal from Ukraine sold for over $80,000. This is the rock that turns patience into profit. But if you think pegmatite is ugly, wait until you meet the volcanic monster that changed the world's jewelry forever. Picture a rock that looks like industrial waste, bluish-gray when fresh, yellow-brown when weathered, full of broken fragments and odd crystals. That is Kimberlite. On the surface, it is a mess. But this is the volcanic elevator that brings diamonds from the Earth's mantle to your feet. Kimberlite pipes are carrot-shaped, vertical blasts of ancient magma, loaded with olivine, mica, and a cocktail of rare minerals. The real giveaway is this. Look for blue or greenish rocks with a brecciated texture, chunks of other rocks, and big rounded crystals. If you see red or purple pyropy garnets, emerald green chrome diopside, or black metallic ilmenite, you are staring at the calling cards of a diamond deposit. The Cullinan mine in South Africa, the source of the world's largest diamond, is just one example. Most kimberlite pipes are barren, but the right one can make you a legend. And here is the science. Kimberlite forms deep in the Earth's mantle, under pressures of up to 700,000 pounds per square inch and temperatures above 1100 degrees Celsius. Diamonds crystallize from carbon atoms under these extreme conditions. Then, hitch a ride to the surface in a violent, explosive eruption. The ascent is so rapid, sometimes in hours or days, that the diamonds do not have time to turn into graphite or dissolve. Along the way, the kimberlite magma scoops up indicator minerals from the mantle, which help prospectors zero in on diamond-rich pipes. Let's talk identification. Kimberlite is gritty, crumbly, and often full of angular fragments. Look for bluish gray or yellow-brown rocks with visible grains of garnet, diopside, or ilmenite. Use a jeweler's loupe to spot dodecahedral garnet crystals or green diopside. The specific gravity test is your friend. Diamonds and indicator minerals are denser than most host rocks, and if you are lucky enough to find a diamond, it will scratch anything. Hardness 10 on the Mohs scale. Value. Raw kimberlite with visible indicator minerals sells for $125 to $150 per carat, with rare specimens fetching more. Diamonds themselves are in a league of their own. Commercial-grade stones go for $1,000 to $10,000 per carat, while investment-grade diamonds can reach $100,000 per carat. In 2024, rough diamond parcels from Mozambique kimberlite sold at auction for record prices. And at Crater of Diamonds State Park in Arkansas, amateur prospectors have found stones worth tens of thousands, like Kevin Kennard's 9-carat diamond, valued at over $30,000. This is the rock that proves fortune favors the bold. But if you think diamonds are the only secret, the next rock on our list hides a rainbow in every crack. Picture a chunk of black, pitted lava, rough, heavy, and about as glamorous as a parking lot curb. That is basalt, the most common volcanic rock on Earth. Inside those holes, called vesicles, nature has stashed some of its brightest gems. When lava cools, trapped gas bubbles leave behind cavities. Over time, mineral-rich fluids seep in, filling those spaces with peridot, zeolites, agates, and even opals. In Arizona, the San Carlos Reservation is famous for peridot crystals pulled straight from basalt vesicles. In India's Deccan Traps, zeolite crystals fill vugs the size of your fist. And in Oregon and Utah, candy opal forms in dull black basalt, hidden until you break it open. The science is simple. Basalt forms from rapidly cooling lava at the surface. Gas bubbles get trapped, creating vesicles. Later, hydrothermal fluids or groundwater percolate through the rock, depositing minerals as they cool and evaporate. The size and quality of the crystals depend on the rate of fluid flow, temperature gradients, and the availability of dissolved elements. So how do you spot basalt worth breaking? Look for dark gray to black rocks with a pitted vesicular surface. Amygdaloidal basalt has vesicles filled with secondary minerals, so look for flashes of green, white, or banded color in the cavities. Use a jeweler's loupe to examine the linings. Peridot crystals are olive green and glassy, while zeolites can be white, pink, or orange. Opal may show a play of color under ultraviolet light. The hardness test helps. Peridot is 6.5 to 7, and opal is 5.5 to 6.5. And always check the specific gravity. Gems are denser than the surrounding basalt. Value check. Peridot crystals from basalt can fetch $50 to $500 per carat, with museum-quality stones selling for more. Opal from basalt, especially black opal, can reach $5,000 per carat. Zeolite vugs from India have sold for $5,000 to $15,000 at international mineral shows. Even small agate nodules can bring in $100 or more if the color and banding are strong. This is the rock that rewards those who look beneath the surface. But if you think volcanic rocks are the end of the story, the next one is even more deceptive because it hides its treasure in plain sight. You have seen it 1,000 times. A chunk of river gravel cemented together, rough, multicolored, and ugly as sin. That's Conglomerate, nature's concrete. Most people see it as nothing more than a pile of pebbles glued together. But this is the rock that built fortunes in gold, diamonds, and rubies. Conglomerates form in ancient riverbeds and beaches, where heavy, durable gems get trapped and cemented over millions of years. The Witwatersrand Basin in South Africa, the world's richest gold deposit, is a conglomerate. Diamonds, garnets, and even sapphires have all been found locked in these rocks. The science is simple. Conglomerates are sedimentary rocks formed from the cementation of rounded pebbles, cobbles, and sand. Gems are concentrated by mechanical weathering and transport from their primary sources, then trapped and preserved in the matrix. Look for rocks composed of rounded pebbles or cobbles cemented in a sandy or clay matrix. The clasts are often multicolored and vary in size, giving the rock a pudding stone look. Conglomerates are found in ancient riverbeds, alluvial fans, and beaches. If you see flashes of red, green, or metallic yellow among the pebbles, dig deeper. Use a jeweler's loupe to inspect the clasts. For gold, use a streak plate. Gold leaves a yellow streak, while pyrite is black. For diamonds and rubies, check hardness and specific gravity. If you break apart the matrix, pan the fragments, heavy minerals will settle at the bottom. Value? Gold nuggets from Conglomerate sell for $50 to $80 per gram, with large, well-formed nuggets commanding premiums. Diamonds follow the same pricing as Kimberlite-sourced stones, with provenance from famous Conglomerate deposits adding value. Rubies and sapphires can reach $100,000 to $200,000 per carat for top-quality stones. Burmese rubies command a five-fold premium. In 2024, a Conglomerate specimen containing visible gold and diamond inclusions from South Africa sold for $18,000 at auction. This is the rock that hides its wealth in the open, daring you to see what others miss. But now, it's time for the crown jewel. This is the rock that has turned more skeptics into believers than any other. In 2019, a man named Kevin Kennard was walking through the dirt at Crater of Diamonds State Park in Arkansas. He picked up a brown, lumpy stone. Nothing special, just another ugly rock. But when he cleaned it off, he realized he was holding a 9-carat diamond, worth over $30,000. And he is not alone. Every year, amateur prospectors at Crater of Diamonds find stones worth thousands, simply because they know what to look for. But the real secret, every one of these rocks, geode, pegmatite, kimberlite, basalt, and conglomerate, follows the same rule. The outside lies, the inside pays. The science is simple. Hydrothermal vents, gas bubbles, and ancient rivers create the perfect hiding places for gems. The identification protocols are your tools: weight, texture, color, and context. The value is real. Specimens have sold for hundreds of thousands, even millions. But the poetic truth is this: nature rewards those who look twice. The difference between a doorstop and a fortune is just knowledge. So, how do you test these rocks at home? Start with the scratch test. Use a steel nail or a piece of glass to check hardness. Quartz and agate will scratch glass. Calcite will not. For opals, use an ultraviolet light. Some will fluoresce, revealing hidden color. Specific gravity is your friend. Weigh the rock in air and in water, and compare the difference. Diamonds and gold are much denser than ordinary stones. And if you are opening a geode or pegmatite, score the circumference with a chisel before applying force. Never smash it outright, or you will shatter the crystals. For conglomerates, break apart the matrix gently and pan the fragments. Heavy minerals will settle at the bottom. Always wear eye protection, and remember, patience is the prospector's best tool. Here are a few more tips and tricks from the field. Gems often feel cooler to the touch than the surrounding rock, thanks to higher thermal conductivity. Hold thin slices up to the light to check for transparency or translucency. Gems are often more transparent than the host rock. Observe the luster. Quartz and opal have a glassy shine, while diamond is adamantine. Use a jeweler's loupe to examine crystal shapes. Prismatic, bladed, or botryoidal forms can help you spot potential gems. And always label your samples with location, date, and context for later analysis. Let's bring it home. Remember Kevin Kennard and his 9-carat diamond? That could be you. You now possess the knowledge of a pro, the X-ray vision to see through the crust and spot nature's hidden fortunes. The next time you see an ugly rock, don't walk past. The difference between a doorstop and a fortune is just knowledge.